Welcome to the fourth section in our series on protein. This section is covering nitrogen balance. Again, this will be another short section, and we're going to start with the definition of nitrogen balance. It's essentially a measure in our body, measuring the amount of nitrogen in subtracted by the amount of nitrogen out. Now remember, nitrogen is a component of amino acids. And the reason we talk about nitrogen balance is nitrogen can be measured. So it's a good way to determine if someone is in a positive or a negative nitrogen balance. So let's start with a weightlifter, bodybuilder. They're a good example of someone who might be in a positive nitrogen balance. Another example would be a pregnant woman. In this instance, for example, the bodybuilder or someone who's lifting weights is going to, for starters, be consuming protein, particularly a lot more protein than usual. But if there is no need for that extra protein, that protein will be broken down, the nitrogen will be wasted, and that energy actually, instead of being utilized, will actually be stored as fat, unless it's needed. But in this instance, amino acids are needed to build muscle. So there is an increased demand for amino acids, which means the protein needs to be consumed. Nitrogen is part of amino acids. So this is nitrogen going into the body and staying in the body. That means there is a positive nitrogen balance. There is more nitrogen in the body than there was before he started this bodybuilding or weightlifting. For someone who is pregnant, this is also another good example because there's essentially a growing life inside of her. She needs more protein. She's building more structures. So again, she's consuming probably a little bit more protein, but also maintaining or keeping more of that protein in her body. The opposite example, a negative nitrogen imbalance, is an astronaut. And this is the more extreme example. Another example could be someone who is bedridden. Maybe you broke your leg and you're sitting in the bed with your leg up, or in the hospital, someone who's in intensive care. Any of these people who are not using their muscles. In particular, in this example, when you take away gravity, your body parts don't have to move against gravity. So there's very little need for energy to move them. So they are going to atrophy. That means to break down. Essentially, the muscles itself are going to be disassembled little bits by bits, and they're going to shrink. Well, what was that muscle made of? That muscle is made of protein. And that protein is going to be broken down. And what's protein made of? Amino acids. So the muscle is going to break itself down. That protein is going to essentially be broken down to amino acids. Those are going to be released. They will be disassembled into carbon. Remember those two carbon fragments? Like when we want to utilize energy, we can take that carbon and utilize that for energy. But what happens? The nitrogen's eliminated. And what's that called? That is called wasting. And that's it for our section on nitrogen balance.